Oh, sorry. So any questions from last homework? I think the diagram, I got some emails about the diagram, and so some of the answers that people typed in may have been marked wrong, so I will look at that later today. Okay, other questions? No? Okay, oh, sorry. Oh, projectors, forgot to warm up the projector. Let's see, so last time, while it's warming up, we started to talk about, some ideas about the Bloom's taxonomy of learning, right? And so there's all kinds of learning, right? So there's many different types of learning. And I think, in high school, the focus is on one level, and then in college, the other focus is sort of on the higher level skills. One thing you can do now, maybe, is you can start to look at job postings or internships for jobs or internships that you might like to have, and then you can see what skills do they offer, or do they say are required. So a lot of times when you look at a job posting, there's like minimum required skills, and then they also have desired skills, desired qualifications. So for sure you want to look at the minimum ones. And for sure you want to look at the minimum ones and make sure that you can get those, and then you want to look at some of the desired skills or desired qualifications, and then in college try to develop those. Okay. And so sometimes I think when employers are looking for college graduates, they're looking for people who have certain skills. And, if you've ever tried to ride a bicycle or drive a car or play a sport, there's a lot of different complex skills. And it takes time to develop those skills. You've got to ride the bicycle, you've got to fall off, you've got to drive. And the more you drive, the easier it becomes. Right? And so, if you look at some of this brain research, what happens is as you do things over and over, sort of the neural pathways in your brain sort of become hardwired. And so then, it kind of becomes automatic. In the beginning, you have to work hard at it and struggle to figure things out. But after time, if you practice those and rehearse those, it can become hardwired, and then it becomes much faster. Okay? So other develop critical thinking skills. If you read a homework problem and you get confused, where do I begin? Try to resist jumping for help right away, even though the help is right there in the homework system. Give yourself 5 minutes or 10 minutes to struggle on your own, and then if you still need help, then sort of as a last resort, as a second resort, reach for help for the homework system. Okay. So after you've struggled, then get the hint reluctantly. So we do have quizzes at the beginning of every week, and then after that, there'll be a short half-an-hour lecture after that, and then a shorter homework assignment. And so you should do keep up with the homework, and then review the homework assignments over the weekend to prepare for the quizzes. So it's good to work in groups. Sometimes you can sort of get an answer, but it's hard for you to explain why. And so if you're in a group, even though you already know how to do it, or you've already figured it out, you've got the answer right, if you can explain it to another person, that can also help review that in your mind and can help sort of cement that knowledge. So it's helpful, even if you're explaining something that you already know. Another good exercise to sort of quiz yourself is to pretend that you have a little brother or a little sister, and you try to explain some of the complex ideas to a younger person. Sometimes in accounting or finance and some of the more technical fields, the CEOs or the executive decision makers are not very sort of technical, don't understand things as well. And so even if you're planning to be in accounting or finance in one of the more technical fields, you'll be working a lot with sort of the non-technical professionals, and a lot of times they want to know why, explain this to me, and then you have to sort of explain things in sort of more layman's terms. So it's a good practice. The quizzes and the tests are sort of closed book, closed notes, but you are allowed to use the TVM calculator, the TI calculator, and so I think that's actually better than a note card, right? Because there's these formulas that it has built in, and so even if you figured out what the right numbers were, if you have the formula, there's always a chance that you might key in the wrong number into the formula, or you might hit a minus instead of a plus, or the division may not work out. You may forget to put parentheses when you're doing the calculation, and so you'll come up with some number, and you may have gotten all of the numbers correct, but you sort of computed, you made a keystroke error, and then your answer is incorrect. And so the calculator sort of helps you by just asking you for the inputs, and then it does the calculation for you, so as you know. Okay, and so last time we started out by looking at a little problem, and we're trying to figure out what is the break-even point. What's sort of the number of units that they have to produce to break even. And it turns out that if you look at the price, you add up the variable costs. Not when you're sort of doing this by intuition, you're not exactly clear why the variable costs are together, but then you kind of subtract those, then you can add up the fixed costs, and then you can divide those, and sort of intuitively you can kind of figure this out. Okay, and so that would be sort of the direct way. On the other hand, we have these frameworks, and they're a little bit of an abstraction, right? And so a lot of times they begin by classifying costs. So what are the variable costs? What are the fixed costs? Sort of add up all the variable costs. So the little subscript T is the total. So figure out what's the total variable cost, find out the fixed cost, and then that, again, subscript T is the total. Find the total fixed cost. And then you can actually, from the price, you can subtract the total fixed cost. And then at sort of net income, NI is the net income or profit. If the profit is 0, right, NI equals 0, then that's when we have the break-even point. And so we kind of went through a little bit of a framework, developed this bigger model, bigger equation, and then when you can actually bring it back to solve the real-world problem. And so this is kind of an example of using a framework to help solve a problem. And we'll go through one more example with CVP, and then we'll start to look at another framework called the time value of money, the TVM framework today. Okay. So last time we left off by looking at this problem, and I mentioned that there is a third type of cost here, and let's see if we can figure it out. Okay. So it says Dan's Deliveries Inc. leases a motor scooter and charges $7 per delivery within its service area. Dan usually does the deliveries himself, but occasionally hires independent contractors whom he pays $2.50 per delivery. For the past 2 months, Dan has incurred the cost below. About how many deliveries must he make per month in order to break even? So what would you do? When you see this problem like this, you go, wow. What should you start to think of? Sorry? Okay. sort of jumping right in, a more structured approach is to try to figure out what kind of a problem this is. So, what kind of a problem is this? And so, through this course, we're going to, do TVM. We're going to do some probability. There are lots of different topics in probability. And when you read a problem, you should first ask yourself, what kind of a problem is this? And once you know what kind of a problem it is, then you can ask yourself, what data, what information does it require, and how do I organize the information? Okay? So, what kind of a problem is this? This is how many frameworks have we looked at so far? Right, we've only looked at one framework, yeah? And what's that framework? It's the CVP, right? Okay, and so, you might pick out break even, right? So actually, another trick or, problem solving strategy is when you start to look at a problem, you might start to read it backwards. Like, jump to the end and read the very, very last question or last statement. Or if that's not it, then go back one sentence and then go back one sentence, right? Because a lot of times they present all this information and then it's like, why are they telling us all of this? But a lot of times sort of the bottom line, the punchline is at the end. And so if you read that, that can help you orient yourself to figure out, what am I looking for? What am I supposed to do? Okay, so break even, right? So you might think break even. And then it's asking about how many deliveries must he make per month in order to break even. And so what's how many deliveries? Sort of the business, is about making deliveries. So each time it makes a delivery, what's a delivery? Or what variable might we assign to the deliveries? Sorry? Cost. So for each delivery, that's sort of their main job, right? And so there are for sure costs associated with the delivery, right? And so when it's asking us, though, what we want to find is how many deliveries must he make per month in order to break even? What are we looking for? Right. So, let's see. It doesn't say. Oh, I forgot to. Oh, wait. Oh, look down here. Look down here. So there is some data. The lease of the motor scooter. So in June, he paid $65 to lease the motor scooter. And then in July, he also paid $65 to lease the motor scooter. Okay? Right. So if you notice, the price didn't change, right? So this would be, I guess we could put in like another type. So this would be a fixed cost, right? The lease of the motor scooter would be a fixed cost. Or maybe there's more room on the other side. So maybe we'll put type over here. So the lease of the motor scooter is a fixed cost. Yes. Right, so there's some data that's up here, and there's some data that's down there. That's sort of like life. If you're running a business, all these things happen, all these invoices come, all these things happen, and so you sort of have to organize them. in order to solve the right problem, you have to know, what are we trying to find? So what are we looking for? The problem is asking about how many deliveries must he make per month in order to break even. And so is there something that we learned that, sorry? Well, there's net income, and net income is it's sometimes referred to as the bottom line. Right? Why is net income sometimes referred to as the bottom line? You've heard of that term, the bottom line? Bottom line. Trying to get to the point, yeah. But why is net income associated with the bottom line? There's something called the income statement, right? The income statement. Maybe some of you haven't learned accounting yet, but what's the top line of any income statement? The income statement has a set format, right? The top line it always starts out with revenue, and then from revenue you subtract something. Those are expenses. You always subtract expenses. And then what do you have? You either have net income, or if it's negative, you have a net loss, right? So sometimes we say NI, and then in parentheses we put L. So this is literally the bottom line. So when they say net income is the bottom line, they're actually talking about the income statement. And the basic structure is all of the revenue and any items associated with revenue would be in the top. And then you have like all these expenses. You may have certain categories of this category, that category. But basically, and you may have intermediate things like, or intermediate results like operating income. You may have income before taxes. You may have income after taxes and before extraordinary events, and so you may have all different subcategories. But basically, you're subtracting expenses in a particular order, okay, in a structured or categorized income statement. But then in the end, you're going to come up with this bottom line net income. So that's why it's the bottom line net income. So that's important. But in order to get started and not be efficient, you need to know what are you looking for? So what is this problem asking us? So net income is always important in any business. And in fact, when it says at break even, what do we know about net income at the break even point? Is right. So net income, right? And so at break even, we want to find out something about when net income is zero. Okay, so net income is always sort of lurking in the background. Sometimes, the point is to calculate net income. Here, in this case, it's kind of lurking in the background. But what are we trying to find? Sorry? Revenue? Revenue is involved, actually. But we want to find about how many deliveries he must make per month in order to break even. And so net income is zero. At the break-even point, we know net income is zero. So we know something about revenue. What do we know about revenue? In order for net income to be zero, revenue has to equal what? Expenses or all of these costs, right? So what are we trying to find? We're trying to find, and the number of deliveries per month. And is there a variable that we call that, associated with that? Something BE? QBE? Quantity, break even, is that right? So if the business is about making deliveries, right? Each individual delivery is like a quantity, is a key. If he makes one delivery or two deliveries, he gets a certain amount of revenue, and then he has a certain number of costs for those, right? So the deliveries is the Q. Does that make sense? Yeah? Okay, so I think one of the first important things is to identify sort of QBE. That's basically, this is the task. Okay, this is what we want to do. So that's what this problem is about. Okay, when it says about how many deliveries must he make per month in order to break even, you can focus on break even, right? And then remember, yes, break even is when net income is equal to 0, right? And then the deliveries, if the business is making deliveries, then that's the Q. Does that make sense? Okay. And so this is what we want to find out, right? And so what are we looking for, right? What do we have to find? Right. So basically, from last time, right, we learned that QBE is basically kind of a function of what? I mean, we saw the form of the function, right? So you can tell me the form of the function, or what are the pieces, the individual pieces that we need. We need the fixed cost, right? So in fact, fixed cost total. So fixed costs total. We need the total fixed cost, right? What did it say? Variable cost, right? Variable cost, and we need that total, right? And what else do we need?
Price.
We need the price. Okay. Sorry, this one was extra. Sorry, it's only 3 things. Okay. Yeah. So when you are trying to solve this problem, you have to sort of start a little bit from the end, start a little bit backwards. What are we trying to do? We're trying to find this QBE. Okay, now I know QBE. So what is QBE? You might remember this formula. Sort of last time, right? It was like, well, let's see, if we add up all the variable costs and then take the price and subtract the variable costs, then we take all the fixed costs and we take this result and we divide it in, and then that should give us the QBE. So you might remember that from last time, or you might sort of remember this formula, or remember that we have our TVM, or our calculator that we can use, right? And so if you do second break even, you can say, okay, I need the fixed cost, I need the variable cost, I need the price, and then this profit is technically, it kind of is a variable, but we've set it equal to 0, so it goes away. And then this is what we can do to that's the information that we need to calculate this Q. Okay, so the worksheet and the calculator is basically saying that in order to find QBE, it's a function of these 3 pieces of information. So in order to solve the problem, you need to find these pieces of information, right? Does that make sense? Right. So if you don't have the calculator, you're kind of forced to remember this formula. Even if you do have the calculator, you might say, oh yeah, this is what it's going to do. But basically, my task is to find these pieces of information. And once I find the total variable cost, the total fixed cost, and the price, if I remember this formula, I'm done. Or if I have the TVM, the financial calculator, I can just plug those into that worksheet and then use it to compute Q for me, the QBE for me. Does that make sense? Okay. So with that sort of as background, what do we do? How do we figure this out? So we have some information, right? The number of deliveries in June, was 30. Number of deliveries in July was 40. So what is that in our problem? Sorry? That's Q, right? So this would be our Q, number of deliveries. Okay. So the cost of deliveries at $2.50 each. So what is this? Cost of deliveries at $2.50 each. When in June, when you made 30 deliveries, it was $75. And in July, when we made 40 deliveries, it was $100. Sorry? So here, the lease is the same in June and the same in July, regardless of the output. So we would call this one fixed. Here, it's a little bit confusing because this 250 is kind of fixed, right? But when we did 30 deliveries, it's 75, and when we did 40 deliveries, it's 100, right? So something about it is fixed, right? 250 each, but when we look at the total cost, it's not fixed, right? So what's going on? We actually would consider this a variable cost. So what is a variable cost? So how do we get this 75 and how do we get this 100? It's dependent on the deliveries, right? So it's, in other words, it's some kind of a function of Q, right? Because the more deliveries there are, the more the cost is, right? So what is it? What's going on? How do you get that in June they were $75? When in June when we made 30 deliveries, they were $75, and then later when we made a different month, we made 40 deliveries. The cost was $100. So these guys are actually 250. I'll just say 2.5 times Q. Is that right? It's 2.5 times Q. So we could say cost of deliveries is equal to 250. Here I have a little more room. 250 times Q. So what is that? Does that remind you of any mathematical thing, mathematical structure, mathematical model that we looked at last time? It might look like the equation for a line. What's the equation for a line, basically, right? Y equals mx plus b. So if we want to say that this is a line, how does it fit into a line? This cost of deliveries equals what? Something times Q plus what? You're putting too many things together. Focus on the cost of deliveries. Right? So the variable cost is a what? The variable cost is a slope, right? And so the slope of a line is what? Does the slope of a line change? No. The slope of the line is constant, right? But the output, the function, the result changes. Does that make sense? Does that make sense? So that's why if we talk about a variable cost, there's something that's constant about a variable cost, right? But that's because a variable cost is a what? A variable cost is a slope. Okay? A variable cost is a slope. So sometimes we want to think about the constant cost per Q, cost per each delivery, cost per, and that's what the slope is, right? It's a cost per quantity. And then once you know the quantity, then you multiply the quantity times the cost per quantity to get that amount of cost. Does that make sense? So to get this amount of cost. So that's why we call it a variable cost. So don't, it's a little bit confusing, but I think it's helpful if you remember that the number that sometimes, per delivery, that is constant, but it's the slope. Okay, it's the slope of the line, basically. And so remember, we're sort of modeling these costs, and the revenue as a line. Does that make sense? Okay, so the key question is, if the output, the Q, right, as Q changes, does the cost itself change? And so here, for the lease of the motor scooter, whether you make 30 deliveries or whether you make 40 deliveries, you lease that thing and you have a contract and it's set. So that would be a fixed cost. Okay? The cost of deliveries, on the other hand, because it changes, right, in proportion to this variable cost, it's considered a variable cost. Does that make sense? Okay. So there's this other one called the cost of gas. And so in June, when there were 30 deliveries, it was $30. And then in July, when there were 40 deliveries, they paid $35. So how would you classify that? What would you call that? Close, right? So it's not fixed, right? Because it changed, right? So that's out. So you might think, well, if it's not fixed, then it's variable, right? But it's not quite the same variable cost as this one, right? Where, you just find some rate, right? So you could take the 75 divided by 30 and you get 250, right? And you take the 100 and you divide it by 40 and you get back the same 250, right? So that's your pure variable cost. Okay? So you take this $30 for cost of gas and you divide by 30, you get 1. And clearly, if you take $35 and divide by 4, you're not getting 1 anymore. So that sort of pure slope here is not the same. Okay, this is the one that's a third type of cost. Okay, And so we kind of listed it here in between the fixed cost and the variable cost, right? Because it changes, right? So the variable cost, clearly changed, but it changed, in proportion to this 250. So in other words, this was 0, right? So it's not purely variable, but it's clearly not fixed. So anyone know, or anyone want to take a guess if it's kind of in between fixed cost and variable cost? We actually call it mixed. Okay, we call it anything like that, where if it changes, so you think, okay, it's not fixed, could it be variable? And then so now you want to see, well, let's take this and divide it by that, let's take this and divide it by that, and if it's the same, then it's a pure variable cost. If not, then it's in between. Okay, so this is our mixed cost. So we cannot go ahead and jump to this guy yet, right? Because we have this other cost here, and we have to deal with it. So how do we deal with it?
June, July, two different equations.
Change the line to an equation?
No, but June and July are two different equations. So both have to
Okay, well, there's something about June, and there's something about July. Okay, there's something about June, and there's something about July. And this formula is in terms of what? It's a function of the total variable cost, the total fixed cost, and the price. So where's the price? He charges $7 per delivery, right? So this is our price. Okay, so we have the price. That's actually done. Okay, and so we have this fixed cost, but we kind of have this other one. We have this variable cost. We kind of have this other one, and we have this mixed cost, right? But we don't have anything here for mixed cost, right? So what do we have to do? So we have this mixed cost. Oh, let me go back to, let's go to something here. We have this mixed cost, right? Gas. But our formula is basically a function of the total variable cost, the total fixed cost, and the price. And I'm saying price is already done. So what do we have to do? We have to take this mixed cost, and what do we have to get out of our mixed cost? Somehow from our mixed cost we have to get what? Does that make sense? Somehow from this mixed cost we have to extract a variable portion, we have to extract a fixed portion. Does that make sense? Because if we can do that, then we can add to this variable, right? And we can add to this fixed, and then we can use the formula, right? Then we can use the worksheet on the calculator, right? So how could we separate this mixed cost of gas, how could we separate this mixed cost into a variable portion and a fixed portion? How could we separate it into a variable portion and a fixed portion? Something about a difference. Okay. So sometimes when you look at numbers, right, Sometimes it can help to put things in a graph, maybe. So when we graph things in CVP, what are our axes? Right, not quite economics, right? Economics would be price and quantity, but instead of price, we have dollars, right? So in CVP, that's how we graph things. Dollars on the vertical y-axis, and then quantity on the x-axis, right? So for June, we would have 30, which we'll just say is about there, and then for July we have 40, and then we have to have a point for about $30 for so here's the x, right, and the y, we go from 30 to 35. So instead of so if 40 would be kind of there, so 35 we'll just say about there. So this is 30, and this would be 35. So any thoughts about how we could take this mixed cost and find a variable portion and a fixed portion? So we have 2 points. And what might we try to do with the 2 points? Find where it intersects the y-axis. So if we found where it intersects the y-axis, would that help us? Sorry? It would be another point. And a point on this vertical axis is like a what? A point on the vertical axis is kind of like a fixed cost. And a slope is like what? A slope is like a variable cost. So what? Variable cost. So if we found the line for the mixed cost, right, the slope would be like a variable portion, right? And the intercept would be like a fixed portion. Is that right? Right? So then we could peel off the slope and combine that with the variable cost, the pure variable cost, right? And we could peel off the intercept, right, from the mixed cost and add that to this fixed cost, and then we could get the total fixed cost and the total variable cost. Does that make sense? Right? So how can we find the line? Right, this point is actually like 40, 35. 40 quantity, $35. And this other point is 30, 30, right? Q is equal to 30, and then at Q equal to 30, it was $30, right? And the other point is at 40, Q equal to 40, $35. Q equal to 40, $35. Q equal to 30, $30. So how can we find the line through the 2 points? Find the slope first, right? So find line through the 2 points of mixed cost in this case, right? So one is find slope. So how do you find the slope? Oops. How do you find the slope? Rise over run. Okay? So, rats. Come on. Sometimes my computer does its own thing. Okay, so let's see, rise. How do we do rise? This is the sort of the delta y over delta x, right? So I'm putting it in quotes because this is really price, right? And this is really Q, right? So how do we get the rise? The rise would be, say, the second one minus the first one, right? So that'll be the 35 minus 30. And the run would be on the x-axis. So the rise would be right here, right? 35 minus 30. And the run would be on the x-axis, right? This one over here. So that would be 40 minus 30. So that's 5 over 10. And so that's a half, which is the same as 0.5, right? Or 50 cents per unit, per delivery. Does that make sense? Yeah? So then what do we do? The usual trick, right? To find intercept, what do we do? Sorry? Right. So to find an intercept, pick a point and plug in. Pick a point. Sorry. Pick a point and plug in. So let's pick 3030. So how do we plug 3030 in to y equals mx plus b? So in this case, y is 30, and m is 1/2, and x is actually q. Oh, right, sorry, 30. And we're looking for b, yeah. So a half of 30 is 15 plus b. So then this says that b is equal to 15. Right? And so you can check by doing 40, 35, right? So this should be y is equal to 35, a half, again, times 40 plus b. So this gives you 20, 35 plus b. And then this also tells you that b is equal to 15, right? So whether you pick the first point or the second point, it's the same, right? Why? Because the slope is the same, right? And so these 2 points are on the same line, and so you find b. Does that make sense? So gas, or cost of gas, equals 50 cents times Q 15. Does that make sense? Yeah? So, finally, we can come to solve the problem, right? Remember, what we need is we need the total, in order to find this QBE that we're asked to find, what's the break-even quantity? No, excuse me. We want to find, it's a function of the total variable cost, the total fixed cost, and the price. We already have the price. And now we can get the total variable cost and the total fixed cost. Right? So we need to get the total variable cost. We need to get the total fixed cost, right? So we already have one of them, right? One of them from the deliveries. It's really, so don't, remember, don't use these, right? Because this is sort of the result, and the variable cost is a slope. Okay, so make sure that you get the slope part. Okay, so we need 250. And then, so this would be from, forgot, sort of general cost of delivery, so cost of delivery, and then this would be for gas, and this would be 50 cents. So the variable cost total is $3, and then this other one was 65 and 15, right? So I think that's 80. Is that right? Okay. So now we can finally put that all together to the QBE is equal to the fixed cost divided by the price minus fixed cost total, sorry, divided by the variable cost total. So that'll be 80 divided by 7 minus 3, right? So 80 over 4. And so we have that the QBE is equal to. Does that make sense? Yeah? Okay. So let's see, right? Just sort of another view, kind of the same thing, right? And so, right, I think, we start with this sort of real world problem, sort of a real world problem. The formalism helps us figure out that we need the total fixed cost, the total variable cost, the price, the net income. In this case, we're setting it equal to 0 and Q. In general, we have this formula. In general, what you can, the way that people use this is they might say, well, we want to have a net income of $10,000, or we want to have a net income of $20,000, or we want to have a profit of $30,000. So we plug that in. We know what our fixed cost is. We know what price we're charging. We know our variable cost, and then we can figure out how much to a certain profit level. Okay. So, but we're not going to do that. Okay. At break even, right? The net income, net operating income, net operating income is 0. And so this is the one that we'll be using, right? And so you just translate it back to the real world solution. Here, again, if you're following along with the calculator, right, we would put in, I think it was 80, right? Yeah, 80. Okay, so this is right. So again, oh, sorry. Second quit, let me get back to sort of the normal starting point. The normal starting point is here, and then if you want to use the break-even worksheet, that's right above the 6. So you do second right above the 6 to the fixed cost, and so then the fixed cost is 80. So you have to do 80, and then you enter that into the worksheet. So then the next variable down would be the variable cost. The variable cost was 3, so you do 3 enter. So we did 80 enter. Okay. Oh yeah, so it's good to do second break even, clear the worksheet, 80 enter, 3 enter, so then it looks like this with 3 enter. So now we go to the next one down, The next one down is the price. Okay, so it's ready to have a value entered in. We do 7, 7, and then enter. Okay, and it looks like that. So the next one down would be the profit, because you could do the target profit. Remember, sort of this is the this is the general formula. Okay, but we're always going to work with net income 0. We'll be working with this version of it. So the calculator does the general version, and so we though will have, you could enter 0 if you want, or just take it and go down, and then when you see quantity equals 0, you push the compute and tells you 20, and then it also puts a star over there, so it lets you know that that was a computed value. So if you might say, oh, what did I put in for the fixed cost? You can actually just cycle through up or down, right? Up or down. You just cycle through those variables in sequence, up or down. Okay, does that make sense? Okay. Okay. Let's see. So we'll say a little bit more about keyboard shortcuts later, but they help you become more efficient in the way that you use Excel. One of the basic concepts in working with formulas in Excel sometimes is you have to lock the cells. So this would be locking to a specific one cell on a worksheet. This would be, leaving, I think, the columns free, but locking on a particular row. This would be locking on a particular column, but allowing the row to be flexible. And this would be back. And so on Windows, if you go through Excel, you can type F4 and then you sort of cycle through those. On Mac, it's this Command T that allows you to cycle through those. But keep thinking about those. And so let's see. Kind of the last time we were talking about sort of big pie in the sky introductory stuff. So today, I think I briefly mentioned that the frameworks in this course are geared to mostly help you with the two particular business core courses, Business 310, Business Statistics, officially called Statistical Analysis for Business Decision Making or Decision Making. I think they can only have a certain number of characters, and so it's kind of like cut off that way. But Business Statistics, we'll be looking at counting, and combinatorics, basically as a foundation for probability, and then we'll be looking at probability. And in particular probability distributions, and to lay the foundation or framework, basic framework foundation to understand what goes on in that class. And then soon we're going to start the time value of money framework, the TVM framework, and that of course is important in business finance. Depending on who you get in business finance, some faculty will assign as many as 3 or 4 Excel cases throughout the term, and so you have like 2 weeks to put together a pretty intense spreadsheet. And so I encourage you to become familiar with Excel. So, understand and categorize the firm's costs. We've kind of basically done that. As I mentioned last time, we'll be going through the TVM framework slowly throughout the term. And then these kind of relate more specifically to probability. Permutations and combinations are very important that we'll get through. We want to understand basically the difference between discrete distributions and continuous distributions. Continuous. So we'll be looking at the discrete binomial distribution, and then this famous bell-shaped curve, the Gaussian normal distribution, and then we'll see if we can get some idea about what this p-value means in statistics, and then find a best fit line. So we'll actually come back to the mixed cost and find a better way. What if you have more than 2 points? We'll come back to that, and also along the way develop familiarity with the calculator. Okay, so hopefully, in order to become more efficient at the gear up for the Excel cases in business finance, it will help you, I think, to use keyboard shortcuts more and more, and so we'll say more about those. And so I think we all kind of figured that out. So now we want to see if we can get started with this next framework, the time value of money framework. And so the question is, what if you could receive $100 today, or some amount, some future value amount in the future, 1 year from now? Which would you prefer? So if the future value amount is $100, how many students would prefer $100? So the choice is $100 today or $100 1 year from today. So we come back next summer, we'll have $100. Would you prefer the $100 today, or would you prefer the $100 a year from now? How many, rough show of hands, would you take $100 today? We'll call that everybody. Okay, and then anyone? Did I miss anyone for $100? Okay, so nobody. Okay, so now what happens if we said, okay, $100 today versus $102 next year? So how many would take 100 today? Maybe we'll say a dozen or so, right? And how many people would take $102 next time? Okay, so no one's raising. So maybe some people are uncertain. Okay. So how many people would take, if the choice was $100 today or $105 a year from now, how many people would take $100 today? Okay, 2, 3, 4. We'll call that, say, 10-ish, or more than 10, slightly more than 10. And how many people would take 105 a year from now? We'll come back. So maybe just 1 or 2, right? 1 or 2. Okay. So thanks. So now what happens if the choice was between $100 today and $110 a year from now? Okay. So how many people would take $100 today? And so now we're down to maybe, we'll call it half a dozen. Okay. And then how many people will come back a year from now for 110? Now we've got another, say, half dozen or so, right? Okay, so what's the purpose? Why would you wait in some cases and not wait in other cases? What's that? Something about interest. So what is? So something about borrowing and what is borrowing? Sorry? Oh, lending. Okay, lending capital. Right. So, okay, good. So, interest is basically, lending for basically using others' cash or capital. Okay, and it's related to time. Okay, so you might ask, how come there's some variation, right? How come some people were here? How come some people were there? How come it's not clear, right? And so, responses were different okay, because students had different internal interest rates. Okay, and so what we need to do is we need to find a common interest rate. Okay, in order to get a set answer, a definitive answer, we need to have a particular interest rate. Okay, so very briefly, I just want to call your attention to the fact that there are actually tons and tons of interest rates. Okay, so in our class, and notice that this is just a page on government bonds in the United States. Okay, and so notice that how even in the midst of a page on government bonds, right? Government bonds, somehow, even though this, and this is just within the US even, right? Somehow these guys, corporate bond rates, snuck into the picture. Okay, so municipal bonds, that's a whole other category of bonds, right? And in fact, there are chapters of books, or probably even whole books, written just about interest rates. Okay, so interest rates vary because of liquidity, they vary because of income tax considerations, and they vary because of maturity, like how long is the borrowing sort of locked up, right? And so there's so many factors, and basically what we're going to do is we're just going to pretend or focus on one interest rate. So we're going to use the calculator. Sometimes people ask, how come my calculator only shows 2 places? How do I show more places? So here's just a little exercise on that. It's just a little commercial here. And sometimes you follow along the time value of money examples, but you get different answers. So there's a setting on the calculator which is right here, PY. So if we do, so let me sort of quit out of that. If you do second PY, you actually want to make sure that all of these values are 1 for now. Okay, and so there's sort of, this explains on how to do that if you have that as a problem. And the idea is that, for example, if you're a real estate professional and you always deal with monthly mortgages, then you should actually set this to 12 and your data entry will be simplified because you're always dealing with monthly mortgages. While you're a student, sometimes you have semi-annual problems, sometimes you have annual problems, sometimes you have quarterly problems, sometimes you have, what did I miss? Quarterly, semi-annual, monthly. Because your compounding changes so much, I would recommend that you always leave this at 1 and deal with the compounding another way. Okay, so that's another thing that can trip you up. Okay, so what we want to do is we want to try to figure out how to model, how to compare these, right? So basically what we're asking you to do is at time equal to 0, would you like $100? Or at time equal to 102, would you like, at time equal to 1, a year from now, would you like $102, right? So it turns out that these are completely different, right? Because money today is actually different from money tomorrow, right? So what you have to do is you have to transfer this $100 from today until tomorrow. So how do you do that? You must be given an interest rate. Okay, so before I didn't give you an interest rate because we were sort of all using your own internal interest rates. But now, from now on, we'll always have just one interest rate. And by the way, remember, even though we only say there's one interest rate, there really are many, many other interest rates. So if we're using 5% as our interest rate, right? What you would do is you would actually say deposit. You would give up $100, say deposit it in the bank, and how much would you get a year from now at 5% interest? Sorry? You get 105, right? 105. You get back 105, right? So by using this interest rate of 5%, right, you would actually multiply it by multiply. How can you multiply this, right? You would take, you're basically using this formula here, where this position out here is a future value, okay? And then what we do at time equals 0, we call this a present value, okay? So what you would do is you would take this present value. So suppose you wanted to decide, I wanted to compare things in the future. You take your present value of 100, and then you give it up, minus, you give it up, and then you deposit it, say, in a CD. You wait for 1 year, and then you get back $105. Now you can compare these, okay? And then you would prefer if 5% were your interest rate. Okay, so it turns out that when we deal with TVM problems, there are actually 6 variables, right? So these are sort of like the environment. Okay, and then these are sort of the cash flows. Okay, so there's in this case, it was a year, and it was 5%. Okay, and so we had a present value of 100, and then this PMT we won't worry about now, and we want to figure out what the future value is. So let me see if I can just do that really, really quickly on the calculator. And so you'll notice that there are these TVM variables right here, actually. So if I do second clear TVM, oh, sorry, let me get back to the normal stage. So we go back to clear TVM. What we do is we can say for n, we put 1. For the interest rate, we put 5. And for the present value, we put in minus 100. And then we actually compute the future value. And that's how you, I mean, in this case, the answer is so simple, right, that you can do it in your head. But for harder cases, you actually want to start to put that into the calculator. Okay. Let's see. So let me adjust the homework a little bit before you guys do that. So I'll send out an email when it's ready to go, and just look at these future value problems, and some of them have to do with 2 years or 4 years or 5 years in the future. So you actually just raise it to an exponent. Okay, so see if you can just work through some of those homework problems, but and we'll go through more of this next time, more TVM next time. Okay? Okay. See you next, right? We have, tomorrow is off. Okay, happy Independence Day.